Hello, and welcome to Cribbage again. So, now you know that the whole thing is a game, and you know how Cribbage, functions. We can actually begin to get into the nitty-gritty of how this thing is optimized and put together to become the best, and how we're going to make the best Cribbage bot ever. So, step one, we'll begin with the discard phase. How do we know what to discard? Well, first we have to know how many points each and every hand is worth, and then we have to take that and we have to turn it into which one is the best hand. So here we have a hypothetical hand, with this being the center card. These six are our hypothetical hand: ace of spades, 2 of hearts, 2 of diamonds, 3 of spades, 4 of clubs, and 9 of diamonds. Now, the first thing you would think of, and that I used in my very first iteration of the Cribbage optimizer, is to just go through every possible combination of these and find the point value for every single iteration, and then just figure out which one has the most points. Now, it isn't very fast. It isn't very fast, and you might think that that's not a big deal since it's just a little bit on the slow side. However, considering we're doing thousands upon tens of thousands upon hundreds of thousands even of these interactions, it really adds up. So we need to find a way that reduces that amount by a significant margin. Otherwise, it is going to take forever. So I've devised a secondary manner of doing so. Here, what we're going to do, instead of just finding every hand and calculating the amount of points per hand, instead we're going to do it how real players do it and just go by the source of the points. As you can see here, I have left some out for clarity, but here I've laid out all combinations that give you points and exactly how many points they give you, and I've organized them by sections. Now, for sets of cards that give you two sources of points, they would be split into two sections with the exact same composition. You'll see why in a moment. Here we have the pairs, all of those pairs. Here we have the runs. Notice how I've split them into +3 and +4, into runs of 3 and runs of 4. Normally they would be just runs of 4. Again, you will see why in a moment. Here we have the 15s, and here we have the flushes. Notice there are no flushes. There is no way we could get a flush. These cards represent how many cards are in each one. The points are here, and the dots are positions where a fourth card could fill in the blank. Now what we do is we take all of this and we shove it into here. What we're going to do is we're going to kind of add the hands. We're going to add these card sets. We're going to add them together. And the way we're going to add them together is if one set of cards, such as this one right here, has one of the, let's say we're going to add, for demonstration's sake, let's add this one to this one. Now here, we're going to end up with 5 cards if we add it straight over. However, if you notice, both of these have the 2 of hearts, and since there can only be 1 2 of hearts, that means that they can merge together into just 1 2 of hearts. That means they can merge together into just 1 2 of hearts, which means we would have the composition ace of spades, 1 singular 2 of hearts, 2 of diamonds, and 3 of spades. Now this is useful because that's the way it works in real cribbage. If you have 2 hands, if you have 2 sources of points in the same hand, then they are counted as different sources of points. However, each card only exists once. So now what we're going to do is we're going to take the maximum in this one, we're going to take the one with the most amount of points, which in this case would be this one with +4, and we're going to move it over into our second area along with all possible additions of these hands. So anything where I can merge together, it goes in here. For example, I can merge together this one with this one with this one to get, because I can merge this one with this one with this one to make ace of spades, 2 of hearts, 3 of spades, 2 of diamonds, which in all is worth 8 points, and that goes over there. So any possible sum of these, in the way I described before, will be moved over to the second area, and then in here the points, now that we've done this, the points will be counted in the same way they would in normal cribbage, and then you just select the highest one, which in this case is the one that I have laid out. Now, that's all pretty nifty, and it does move significantly faster than it would with it moves significantly faster than it would with just standard go through every hand, find the points. However, we still have to take into account that it's just slightly faster. We're still doing so many calculations. I think the specific amount is 52 times 51 times 50 times 49. Times 59 is the total amount, which that is a big number. Even though we've shortened the amount of time it takes to calculate, we haven't shortened this massive number. I think that the total amount is 52C4 or 52C4 or 52 factorial divided by 48 factorial. Yes. So still, that's a massive number. What are we supposed to do with all of that? What are we supposed to do with all those numbers? I've got an idea. We shorten them. You see these things right here? These are suits, and there are 4 of them in every deck. Now, here's the thing. Suits don't do anything when you're calculating points. All they do is they tell you when there's a flush. So if there isn't a flush, there's no need to account for suits. And that literally chops the deck in 4. All we really have to do is remove the suits. Just take them out. Make a quick note that these are two different. Make a quick note that these are 2 different cards because they're both 2. And then all we have to do from there is just make a quick note that says this is A, this is the probability, we say this is A, this is the probability that it's a flush, and we have B, and this is the probability that it's not a flush. And then we take those probabilities, average them, and then multiply it by the amount of points that a flush gives you. It's that easy. And then the number that we have to sort out goes all the way down to 13 times 12 times 11 times 10, which, well, slightly more than that. It's around that range, but that is a way smaller number. That is a way smaller number. Instead of having to account for all 52 combinations of numbers and suits, and having to deal with the combination of 4 of those every single time, we only have to account for 13. Well, more than 13, but you get the idea. Amazing. Come to think of it, a good bit more than 13, but still, way smaller number. Anyway, Moving on, you may be wondering, why do we need to calculate every single hand, Zachary? Why couldn't we just calculate one and call it a day? Well, professional cribbage players don't just think about what their hand is, they think about what their opponent's hand could be. So here we have just a visual representation of how we're going to calculate what our optimal hand is. What we're going to do is we're going to start by calculating the opponent's hand. How are we going to do that? We're going to predict the future. How are we going to do that? Well, we're going to go through every possible combination that the opponent could get in the way described. And then what we're going to do is we're going to take all of these hands that it comes up with for every hand of 4, for every possible combination of 6. And then we're going to find the most likely one to come up. And then whichever most likely one it is to come up, we're just going to plug that in for the opponent's cards. Incredible, right? Anyway, we're going to take that info, and then we're going to take that info, and then we're going to run our calculation of what, for our specific set of 6 cards, is the best 4 cards. But we're also going to note by which cards we throw into the crib, whether that gives the opponent any points, or whether that gives us more points based on what they discard. Thus giving us even more points if we do it right. So and then next, we have the counting phase. Now, the counting phase is already, we have a pretty good idea. I already have a pretty good idea of what's going to happen here, and it's going to involve predicting the opponent's hand, and it's also going to involve a little something called minimax. Minimax is an algorithm that is used in competitive environments. It's one of its primary uses, at least that I can think of, is in chess robots. But basically, it's an algorithm for finding out which path you need to go so that the best number is selected for you. And here's how it works. Let's say that we are player A and our opponent is player B. And we need to figure out which choice we need to make all the way at the top here so that we get the biggest number on the bottom. But here's the thing. Player B wants the smallest number on the bottom and will always pick options relating to the smallest number. So how do we assure that the biggest number is picked? So, how we do this is we do this via a bottom-up sort of deal. Down here, we all at the end of the line, no matter what is picked, we're always going to go for the biggest number. So over here, we can confidently say that we're going to pick 5 over 4 because, again, we're going for the biggest number. So over in this branch, we're going to pick 5. We can move that up here. We're over in this branch, we're going to pick 5. Over in this branch, we're going to pick 8. Over in this branch, 7 is the biggest. Over in this one, 7 again, the biggest. Over in this one, it's kind of redundant, 7. Over in this one, 5 is the biggest. In this one, 8 is the biggest. I can't write with my left hand. And in this one, 10 is the biggest. Now we go to player B's turn. Player B is, no matter, once we get to this stage, player B is always going to go for whichever, player B knows which one we're going to pick at the bottom, and based on that, player B is going to pick whichever would give us the smallest number overall. So we're going to take every number in this area and we're going to find the smallest one since it's player B's turn. Over here it would be 5, over here it doesn't matter, it would be 7, over here the smallest number is 5, and then over here the smallest number is 8. Now it's our turn again. We know what B will pick, and we know what we will pick, and then we know what B will pick based on that. So we need to pick what will give us the largest number based on all of that previously collected data, which means, you guessed it, we're going to find the biggest numbers again. Here we have 5 and 7. 7 is the biggest number. Here we have 5 and 8. 8 is the biggest number. Now, now player B is, I did this out of order. And now player B is going to pick the smallest number. And I apologize, sports fans. I did this wrong. It turns out player B was actually going first. So I guess that's kind of unfortunate for us. But regardless, player B is going to be looking for whichever number is the smallest. Again, so repeat the step as before, 7 or 8, 7 is lower, 7. Meaning that if we go through this whole tree, we are reasonably confident that 7 will be selected. Meaning that based on the choices here, meaning that we can tell meaning that our calculator can optimize cribbage by picking the pathway that gets us to 7, assuming of course B also plays perfectly. And that's a pretty poor explanation of how minimax works. If you look it up online, there are many different guides that can probably explain it better, but that's basically what we're going to be using for the counting. Since we know since with these as points at the very end, and we can plug in the opponent's hand here for picking which cards they're going to play next, and so on and so forth. So that's about it for how we're going to optimize cribbage. Obviously, beyond this point, we pretty much just have the semantics of how we're actually going to plug everything in, and also this little bitty thing towards the bottom. See, as I was putting all of this together, I realized, man, people have pretty traceable shuffle patterns. Counting cards, at least with a computer, might be a real possibility that I will look into if I have some extra time. Which, if I can pull it off, will make this so much better than any other robot regarding cribbage that I have made in the past, like not even close. So this is a potential future for the project, but aside from that, it's just going to be taking all of this and implementing it in a manner that a computer can, understand. And dealing with the semantics such as, well, how are we going to break this down even further? How are we going to deal with the possibilities of the center card? How are we going to plug in the opponent's hand into selecting ours, etc., etc. So that's about it. I will see you in the next one.